Right, another method now is a bit more complex, and the main problem with this particular setup is if you want to do some deep sky, it can be a bit expensive to a beginner, and a lot of the times where it mounts up, the cost mounts up is usually is actually getting a CCD camera. Now CCD cameras are basically cooled cameras, and what these cooled cameras, they're basically cooled to as low as -27 to -30 below the ambient temperature. And what that does is, with these cameras are cooled in certain extent to allow you to do long exposures up to 2, 3, 5, 10, even further than 10-minute exposure times, and per frame. And what you're doing is you're trying to capture as much light as possible, and these cameras are cooled that much that they do not produce noise or very little noise, and which creates hot pixels, and that's why they have to be cooled. Again, CCD have specialized chips that are so light sensitive that it enables you to collect the faint objects, especially for deep sky objects. And as I said before, is probably the most complicated, complex start for beginners who want to do a basic setup for astrophotography for deep sky imaging. It is very complex, and it's a big steep learning curve as well. Alright, and you will get problems. As I mentioned before on my last guides before, I mentioned about the equatorial mount. Now, if you want to do deep sky imaging, you need a really good equatorial mount, alright, and get a mount that it's going to be, the payload is very, very important, alright, and you need an equatorial mount, ideally with go-to, or maybe a motorized drive mount, so that you can track the object that you're trying to image as long as possible. But you need a German equatorial mount to be able to do astrophotography for deep sky. Alright, and the mount is the key. Now, I've heard over time and time again through many forums that you need to spend £1,000 on this and £1,000 on that. But if you've got a good, decent equatorial mount to begin with, an EQ5 or an EQ 3.2, as long as you've got a sturdy mount and that can track sufficiently, and it's polar aligned, don't forget the bit on my guys, the telescope, the scope has to be polar aligned, so the mount needs to be accurate as polar aligned as possible. Alright, you can get some good, awesome images for deep sky. But again, the mount is the key, without a doubt. And I've had a lot of guys who want to start out this particular astrophotography saying, oh, I need to have this big scope and all that, and this camera. It's great that you can get, you can fit an 8-inch reflector on this mount and fit a decent camera, but the mount will struggle. So the mount is the key. Now, never ever buy a big telescope and an awesome camera which adds all this weight to a small mount, because basically it's useless. The mount, what that does, enables you to track objects accurately as possible. Now, if you overload this mount, this will not track very well, and you'll get star trailing. Alright, and that's a problem. You need to invest on a decent mount. First thing, everyone who starts out this particular astrophotography is get yourself a decent mount. Now, the good thing about astrophotography for deep sky, you do not need a big telescope, alright? And The key is with deep sky is you trying to collect light photons. Now, a lot of guys saying, you need a big telescope, you need this sort of setup, not. Believe it or not, you just need a small little refractor or something, and it's ideal. The main point of deep sky objects is it's not all about aperture. Aperture is only good for when you're doing visual work, and visual work is important. However, for when you're doing CCD imaging, it's basically how fast your scope is. Now, how fast it is basically it's photical ratio what you're looking at. Now, photical ratio is how fast that light can travel down the tube as quickly, so that all the light photons get collected from the camera. It's all about photical ratio. Now, photical ratio is very important. The quicker you can capture that light, alright, and the faster you can collect that data, and that's what it's all about. That's the key. Now, believe it or not, I mean, this 80mm refractor, I can get some absolutely fantastic images, alright, through this because it has a fast photical ratio. Now, this telescope is usually an f7. I mean, this telescope is an 800mm photical length. So basically, it projects that light to photical length of 800mm down the tube. All right, and from there, that photical length is to work a photical ratio divided by the aperture of the telescope, of the main telescope. So basically, you're working out that, and you can calculate this. I mean, this is an 800mm tube, photical length, divided by 80mm of the aperture of this telescope, and then you record that, and it'll give you a photical ratio of 7. All right, and it's okay. It's relatively fast, but you want to get lower. That number. Now, that number is very important. So the lower that number, the faster that light can travel. Now, reflectors are really a good optical instrument, to image, because they have f5 and usually lower than that, and they can capture the light really quickly. However, there are ways around this, but it does have to be invested a little bit of money. And like I say, for a lot of guys who want a faster scope, there are ways to do it, and you'll need something like this. F7 is usually alright for this telescope, but this device, what this is a photical reducer. Now, photical reducers, what that does is basically, it's like a Barlow lens, which increases the photical length. However, this is the opposite. What this does is it halves the photical length. Alright, so depending on what sort of focal length, but this one it's got this number here, this times number here. It's around about 0.8 times. And what that does is, that 0.8 times photical reducer, it basically attaches onto the CCD itself, and then it goes through the tube into the focuser and then gets clamped on there. Alright, and then what that does is it reduces the photical length to a certain degree. Now, I believe that this photical reducer reduces it to about reduce the focal length to about 500. I think it's around about 534 or 35. And what that does, it reduces the focal length to about 5.5. Now, 5.5 is just as quick. All right, you're looking around about f6 and below is what you're looking for deep sky imaging. The lower that number you can get, the more you can get that light collected. However, they cost a little bit of money, these photical reducers. So ideally, I mean, get a refractor with a shorter photical length or photical ratio. But you know, a device like this, it costs about £100 or something for something like this. But you want to reduce that focal length down. The only reason why this is expensive is it's got a field flattener as well. It's not just a focal reducer, it also field flattens, and what that does is when you're imaging, it reduces the curvature, because that's what refractors tend to do, is they tend to curve the stars and all that. So a field flattener basically flattens the field, so all your stars are pinpoint. Alright, with reflectors, reflectors have a fast focal length, which is ideal. However, they suffer from something else. Alright, and you need this device. For reflector owners, alright, if you're imaging and you're taking the pictures of imaging and you notice some of the stars will appear like comet trails and they'll look distorted. Basically, it's coma. And coma is basically the curvature of the main mirror that produces this coma. And this is a device, this is another lens element that you put on reflectors to eliminate coma to a certain degree. Again, you pay around about £50 to £60 for one of these, but what this does is, like a field flattener, it basically corrects the coma on the reflectors and reduces or eliminates this comet star trailing or the stars getting distorted. A little handy feature, alright, and it works quite well. You can get different varieties of coma correctors. Some actually reduce the focal length as well, so it speeds up your optics, or you just get a standard one like this one, which just basically eliminates coma. You can invest on these and to get the best results, but however, you do not have to invest on these devices alone. I mean, F7 is probably fast enough but the whole idea is, if you speed up your optics, is what that does is it speeds up your exposure time, and exposure time is, I mean, it literally halves it. Literally, the more you speed up exposure time, the better you can get those light photons on and more light collected. And that's the key. It's faster the optics. It's not all about aperture with deep sky imaging. Okay, so that's what I'm trying to tell you guys, that you do not need a big telescope to do deep sky imaging. Alright, because basically what you're doing, as long as the mount is accurately tracking, alright, and the mount is the key to this. Alright, the mount is the #1 key to start on this type of astrophotography. So again, once the mount's tracking fine, you're just collecting that photon light. That's all you're doing. That's basically what the setup is all about. As I mentioned before, I mentioned about the mount, and I also mentioned about focal ratio being important for this type of astrophotography. We're now going to go on to the CCD. Now CCD is probably going to be the most expensive item you're going to do if you want to undertake astrophotography for deep sky. Bear in mind, I mean, you could pay thousands and thousands and thousands of pounds for a CCD. However, in the astronomy market today, you can actually get some budget CCD cameras now that start to appear on the market, and alright, they do work, and they work really well, and you get some excellent images. Again, many years back, a lot of these special cameras, you could not pick them up for you expect to pay £1,000 easily, and there still are, but there is a lot of beginner ones now starting to come out in the market, and you can pick them up around about £300 to about £600. And usually these cameras are you can get an Attic Titan, which is a good CCD. QHY do one, which is a QHY6, which is another good beginner CCD. They are coming out. I think there's a Star Shoot one as well, an Orion Star Shoot that you can get. That's another good one. But the only reason why they get expensive is because of the chip. Alright, and that's really basically what you're paying for. You're basically paying for the chip size and the electronics involved with a CCD. The rest of the stuff is just, you know, it's just a pelter cooler fan and the electrics inside that. But basically you're paying for the chip. Alright, and that's what makes it expensive about these cameras. Because of the chip and the electronics involved, that's why hence the price becomes expensive. Now you can get some lot cheaper CCDs and they work quite well, but expect the chip size to be small. You can get different types of CCDs, alright, and you can get a mono and you get a colour. Now they both have the advantages and disadvantages, but to begin with, I don't want to go too much in depth with CCDs, but my best advice is, if you're starting out and you suffer a lot of cloudy, you're in an area where you have changing weather, which is quite, you know, you get cloud conditions all the time and all that, I would not get a mono. Mono might be more sensitive and collects more light better, but you have to invest on like colour filters to get colourful images now. Although you can get black and white images, because the mono gives good black and white images. However, again with mono is you can get a mono, alright, and they do work quite well, but you have to invest in special filters. Then there's a different setup. You need a filter wheel set up and all that. So it's not really ideal, and you need to take loads of exposures as well with mono. However, I prefer to get a colour CCD, alright, and you can get them in the market, and you know, they have a relatively decent chip size on there. They won't offer as good images compared to a mono, but it's close, you know, it's close enough. And the good thing about colour is you don't need to have the hassle with filters and collecting certain filter lights patterns and stuff like that. The good thing about these cameras is they're basically, as soon as you plug it in, get into focus, and you start imaging on your setup, you just take pictures and you that's it. You're off. You're on. You know, you're just capturing images and light photons. So a CCD colour is the way ahead for beginners, to be honest with you. It's a good start. Again, this is you can get the QHY6, which is quite good, and expect to be able to pay around about £300. However, if you want some really good images, I mean, I've gone for the QHY8L. Again, it's not £1,000 mark CCD. I actually paid this £899. It sounds a lot, believe me, it is a lot of money. But like I say, you can get some ones on the market around about £2, maybe £3 grand. But I don't have that kind of money, so I went for the QHY8L, which is this colour CCD, and it offers a massive chip as well. Alright, so I'm going to show you now. As I mentioned before about the colour CCD, it's basically the same sort of setup. It's basically, you can attach it just like a webcam, and you know, it unscrew that and it all slides out. Here is this bit here. This is the photocal reducer and field flattener, and it's basically attached to a T-thread adjustable thing, and it clicks on there. Alright, reason for this gap is because of the field flattener needs to have a back focus 55mm, which basically you need this lens to bring to focus to this camera, so there has to be a certain gap. So that's why there's a space here, and basically that just set up in there. As you can see now, we're going to take a look at the chip itself, and you can see there it's a big chip, alright, and that's what you're paying for. A lot of times on these CCDs, you're basically paying for the electronics, and hence the reason why they're so expensive. You know, they can be in various sizes and different sort of brands. However, this is a good CCD, good colour CCD camera, and it's absolutely brilliant. Alright, and again, you can get cheaper ones, and they just do as just as good. But that's what you're paying for, is that chip. Now that's quite a relatively a big chip, but you get smaller ones than that. Again, it's not always about the chip size. I mean, bigger the chip is, the more you can get light photons in there. I mean, but that depends on the telescope you're using as well. So, like I say, you don't want to, you don't have to get a big chip. But to start off with, you can get some really good CCDs. But I'm not going to go too much on chip size, right? Because it can get, it's a minefield. But that's what you're paying for, and you know it looks kind of basic. And you have it's powered by USB. So basically, that USB is connected to the laptop, all right. And then you have an external power source, which is this one here, and it runs along, and it runs on a 12-volt system. And believe it or not, it has to run on a separate battery. Now the reason why I said it has to run on a separate battery is that this CCD drains a lot of power. I mean, this drains about 4 amps to 5 amps per hour. So you need a big battery. So a 17 to 20 amps per hour battery is needed. Do not put this camera or to connect it to another that's sharing the mount and all that, because what you're doing with a camera is you'll start creating ground loop, and ground loop is it basically puts a false color on your images, because there's reason with this false color in your images is basically there's not enough voltage getting to the camera. So basically this CCD has to have its own power, its own separate power. So you need, this is reason why, you know, as well as paying a lot of money for a camera, you've got to pay for an external battery to run it. Alright, you can actually get a power source, additional power source that runs on the mains, alright, which is a much better option. But if you're going to remote sites and all that, it's well, it's not really feasible. So you have to use the DC supply, which you get with the kit. And again, it runs off its own power. So, but that's usually the reason why it's running off its own power is basically for the fan, because the fan has to be on, so it cools the CCD chip, and that's why it needs that sort of power to run it. Again, the USB basically transfers the data to the laptop. Alright, and that's how that works. The thing is I need to cover is as well as investing in a CCD and a decent mount, which is key for deep sky objects and imaging, you know, for deep sky. The one thing I need to cover is, I mean, the mount can track quite efficiently. If it's polar aligned, it can track quite well to up to about 2 minutes or so. But then what will happen is when it's tracking for a certain amount of time and you're imaging a galaxy, for example, you start to see some trailing on the stars. Now this trailing is basically the error between the gears, and the mount will track sufficiently enough, but as soon as you go past a certain exposure time, you know, 2-3 minutes long, you start to intrude trailing. So this is why this particular astrophotography becomes complex. So the CCD will give that image, and you'll see this star trailing. Now there's a process that we can actually eliminate, and the process is auto guiding. Now auto guiding is basically is a camera that's attached to a telescope. Alright, and I mean this is a guide scope. Now the guide scope's attached to it could be a webcam, or it can be another CCD. This is another CCD, but however you can use a webcam to do this. And what that does is that this guide scope is basically, while your imaging train is trying to image, this guide scope, what this does is it images. You want to set up this guide scope to lock onto a star and focus on that star. And what this the guide scope does, at the end here, this camera here, alright, will send the data of a star. Now the program that I use is PhD guiding. Now PhD guiding is done by Stoke Labs, and it's a separate software that you have to use. And this software will enable you to lock onto a star, and what the camera does is, as you see here, is you've got the power supply for the USB to transfer the data of the image. This lead here is an ST4. Now this ST4 lead is connected to the actual drive system, and it's connected to this ST4 auto guider port. And what this does is, as the program, as the camera detects movement of star trailing, what that does is it sends the data back and tells the mount where to move and where to correct all these errors between the gears and all that. And what that does is it prevents star trailing, and then it will allow you to extend your exposure times longer. I mean, you can extend it up to 5, 10, 15, 20 minutes, even longer than that. Now you get two different varieties. You get the guide scope method. Alright, this is a finder guider. I mean, you convert this finder into a guide scope, but usually there's a process called piggybacking, alright, which you can attach another telescope on top, alright, on there, and that's called piggybacking. But again, it's still guide scope, alright, or finder guider, alright, and all that is just basically, you know, it's the same sort of process. There's another process called OAG, which is off-axis guider. Now basically it's an adapter that you fit onto the main drivetrain, alright, and there's like a little mirror inside, and this mirror is attached to basically a camera on top into the drivetrain. So basically that does the same similar process, but the actual guide scope or guide camera is actually along, that shares the same light path as the main scope. Alright, so you're catching some of the light that way. However, OAGs can be a bit difficult to set up for beginners. So I would seriously recommend, if you want to start doing some guiding, then you need to start off with just a normal simple finder guider or guide scope. Alright, and that's the way to do it. Now I'm going to cover that on a later date, how to use a guide scope and the setup and how to track the stars. Alright, but it's an easy process. It's not too taxing, but you know, it costs a little bit of money to do. And you can use a webcam to do finder guiding. You do not need a complex system to do some guiding. But the whole idea with guiding is you get the best high quality images when you start doing guiding methods like this. And however, with guiding, you do require a go-to mount to do this. However, there are other processes to do it. Alright, with a guide scope, you can actually get a device called this, a USB guider. There is another one called shoestring as well, which is a similar one. And basically, this is usually, if you haven't got a proper guide camera, you can use a webcam for this. Alright, and the webcam attaches here. This is the plug for the webcam, alright, and then here is where your ST4 usually goes as well, alright, and the ST4 gets connected on there, and it enables you to connect a webcam directly to the computer, and then the ST4 from that box powers up and your webcam will be able to run as a guider. Alright, but you need something like that to run it. However, a lot of the guide cameras like the QHY5, alright, is fantastic. There's a Starshoot one from Orion, which already has the ST4 port, and it has the powered USB lead, and you can disconnect straight away. These cameras usually cost around somewhere around about £100 to £200, but however, quite sensitive as well. Alright, but basically all that is a miniature CCD. That's all it is. It's not cooled. Hence the reason why you don't need an external power to power it, like you do with the main CCD, because that's needed. But you don't need it to be cooled. Alright, you just basically it's bright enough to capture some of the stars that you can lock on, and that's how it works. It's simple as that. But again, this setup here gives me some outstanding views, alright, of images for deep sky. Well, and if you've looked at Astronomy for Beginners forum, you'll see some of my images. I've got M42 Orion Nebula and the Running Man Nebula with this scope, an 80mm refractor, with a decent CCD with a guide system, all attached to a netbook system that does all the capturing software and all that. This setup here, a lot of people say expect to pay thousands. It is for this sort of setup, alright. However, you can still do deep sky imaging with a guide system, but use a DSLR. You can do it, but however, I can't show you a DSLR because I don't actually have one to show you that it can be done with the DSLR. But the process is basically the same. Alright, the DSLR, instead of the CCD attached to the computer capturing the images, you just got a normal DSLR and it's capturing the images itself. However, if you want a guide system, you still need that power for a guide scope to run directly to the laptop for you able to guide. Alright, and that's, you still need a laptop to run it. It's just the good thing with DSLR, you do not need an external power or laptop to run it. Alright, that's the only advantage of DSLR. Again, you can use DSLR or a CCD camera, but you can't use a webcam for things like this. Alright, and you have to have a CCD or DSLR to achieve this, to get somewhere with deep sky astrophotography. But again, it's very complex. I hope that this helps anyway. I mean, this is I'm trying to show you guys, as basic as I can get it to describe to you. Like I say, I hope this helps. Feel free to ask any questions on the forum regarding the subject we just talking about. Alright, and like I say, thanks for watching, and goodbye.
Well, certainly the more central and southern parts, it'll be a fine dry day. Good deal of sunshine to begin with, clouding over somewhat later on. But for Scotland, Northern Ireland and Wales, certainly the more central and southern parts, it'll be a fine dry day. Good deal of sunshine to begin with, clouding over somewhat later on.